Great, that's fine. Anybody using step functions? Good. Anybody using AMI pipeline to create AMIs? Good. All right. This means we have good topics you would understand, and we're going to explain each and every word in this, except for any other names that you see and dates. We're going to talk about operating system patching. We're going to talk about what is in-place patching. We're going to explain Systems Manager. Have you used Systems Manager? Who's not using Systems Manager? Who's using Immutable service? Okay, great. Okay. So we're going to cover all these topics, and first of all, we'll define what is patching. Patching is basically you fix a software flaw. Now, if I write a program, it's basically a few kilobytes. Now you need to think about an operating system. An operating system has gigabytes of functions and subroutines and programs and libraries. So you could imagine the scale at which the operating system could be flawed. So you need to respect when Microsoft sends so much updates every month. Please give some respect to that, because it's a lot of hard work and a lot of flaws, and therefore you have to fix it. With that, they also improve new features, like with new libraries you can cut down the code, you can reduce everything. So therefore, patching is important. So that's going to be our logo. You must have heard these famous flaws of the OS. Two of them are actually hardware flaws of Intel, like Meltdown and Spectre. But Eternal Blue, if anybody is aware of WannaCry, it impacted a lot of machines. And it turns out that 37% of people knew that they could have patched the machines, but nobody did. And 54% actually knew that these are the vulnerabilities available, but they did not do anything about it. So always patching is absolutely important. One thing to understand with EC2 is EC2 gives you compute capacity. They provide you AMI. Amazon is very kind enough to give you the AMI, but it's usually something that gives you up to date on that particular day. The moment you launch your EC2, it's your responsibility. You must patch if you want to patch. If you don't want to patch, go back to the next slide. You have vulnerabilities, so you probably have to fix them. So they don't patch all these things, it's up to you. So that injection, that's the patching logo for today's session. So how to patch your EC2 machine? It's quite simple. So on a Linux machine, if it's a RPM based machine, you would run yum update. And on a Windows machine, log on to settings, do an update. That's it. Probably reboot it later on. This, you would probably do it on your personal laptop or your VM. If you're doing at scale, this is something that you don't have time to do, isn't it? One thing that we have to understand, we had a previous session about serverless and containers and whatnot. But EC2 is something that's there. It's going to stay there for a long time. So this is something we have to acknowledge and respect that. So this is a site, AWS does not publish what's the number of EC2 instances available. We have today 149, this is last week's data, 149 EC2 instances in Sydney. So that's a lot of EC2 instances, right? Now, this next few slides, we're going to talk about in-place patching. So in-place patching, simple definition, you have your laptop, you're patching them one by one, every day. Everybody uses your laptop, everybody patches it. So it's simple, it's in-place patching. You have an app, you go and update an app, it's in place. So that's, you clearly defined it, what exactly is in-place patching. Now, how do you automate this at scale? You have hundreds of EC2 instances. How do you do this? Using PowerPoint, first step. PowerPoint is very easy. Afterwards, it actually took just a couple of days, a couple of hours actually, and then to finalize everything, it took days. But that's the first thing. Always start with PowerPoint if possible, then go back and try to fix. We'll talk about Systems Manager. Systems Manager, have anybody not heard of Systems Manager? Great. Okay, Systems Manager is something like your config management tool from AWS. They have a different nice definition. The way I see it, it's like a poor man's Ansible Chef Puppet solution. You can manage everything, all these EC2 instances at scale, and it's available to you. So you actually don't need anything. It's available free of cost. Start using it. All that you need is an IAM role attached to instances. You need connectivity to SSM endpoint, and that's it. So first thing that we have to understand is you can, the Systems Manager, you can create baselines. Patch baselines are like you explain that, hey, Patch Manager, I want to patch my machines to a certain point historically, like 7 days after the patches were approved or released. So if Microsoft releases something today, my patches would not be up to date, won't be approved, won't go into production 7 days later on. So you can apply these rules. So this is a screenshot of how it looks like. So Patch Manager, that's a simple section there. There is no actual tool that does patching. It's what Amazon does, what Patch Manager is. It uses intrinsic tools like documents, run commands, and then combines everything, and it provides you Patch Manager. Right. So the first step you probably do with Patch Manager or to patch your machines is you tag your instances. So let's do some aggressive thinking of how you want to patch your machines. Imagine you have a pipeline, or you have a team who are still using EC2 instances, and you have hundreds of EC2 instances. You divide them, for example, 4, 25 would be dev, 25 QA, 25 UAT, and prod. You tag them. So tagging is important with the tag patch group. AWS does not enforce any patch tag name by itself, but patch group is actually one enforced tag. So if you want to do this, you must apply patch group for this particular example of patching. So the first step is we'll tag our instances. You tag them based on whatever you want. No rules with respect to the values, as long as you remember what you have applied. In this case, we apply dev, prod. If you have Linux machines, add them based on your choice. But remember what you're tagging your instances with, what you intend to function it with. So in our example, you had an aggressive strategy. You want all your machines to be patched, but your baseline, you would relay all the patches at an interval of, say, 7 days. So every week, first week you'd apply the dev patch, second week QA, third UAT, and fourth week prod. But here's something that you have to do. When you do an application deployment, you want to make sure that your patches are in line with your application. So if I get an update on dev, of course, Microsoft and open source distributions releases updates on a daily basis. So if I update my QA, I might still get a latest update which I have not tested in dev, right? You have that differences. To avoid those, you could create multiple baselines, but then align in such a way that in the end, all of them, in your production when you go, you can have that, okay, I've tested this in dev and it was okay. Nothing went wrong. So this is why you would create multiple baselines which aligns with your patching strategy. So creating a baseline, the most important thing is what do you want to approve? So approval rules, you get critical updates, security updates. You can go quite granular. You can go up until the application. If you have Nginx running and you want to make sure that Nginx is not updated, you can update that here. You can tell that, no, I don't want to get Nginx updated here. I would do that in my release pipeline of my app. Don't bother. But so that's something you can define and control in baseline. Right. So there is some other feature called State Manager. It enforces compliance, which is something that here we could use. State Manager, think about you want to ensure that your instances like IP tables for Linux or firewalls for Windows, you want to enforce that these particular ports or firewalls ports are never open inside the OS. And you want to enforce that such a way. So you can use State Manager. State Manager, and it's like a cron. You tell that you want to run this for a certain period of time, and you want to do what? that do what is defined by a document. Document is like your Ansible playbook or your chef recipes. So these documents define what you want to do, the action. So first step, if you do this part, to explain you what we are doing here is, this will populate the patch compliance. So as how frequently you patch them, it will verify and update the patch compliance section, which we will see later on. So as I said, it's a simple cron expression. You want to explain, you want to tell that I want to run it every day, and I want to do what? The do what is in the document recipes and cookbooks, right? And the most important thing is you associate this with your tag. You don't want to, and in fact, the document you could do control scripts as well. So you want to reboot your dev instances every day for some reason. You could do that with State Manager, and you could update the tag. So make sure you tag it properly. So in this example, we have 4 different associations. Simple, nothing magical over here. Now, maintenance window. Now we have established that this is the baseline. I want to go with no Nginx, for example. I want to update past 7 days of everything. You have established all the ground rules of what your machine should do. The next step is you define patch my machines tonight. Patch my machines every 4th week or 4th Sunday of the month. This is how you do it. So maintenance windows explain. It's again a think about a cron expression. Technically, there's very little difference between association and maintenance window, but when you do a state manager association, it populates the compliance. When you do with maintenance window, it's just one-time activity, just gets that done. These days, we are moving all the cron that we are doing on EC2 instances to State Manager because it's so hard to go inside and find out which cron am I running. So it's kind of very useful. Under maintenance, once you define the time, you define the time here in cron expression. You tell what you want to do. This is the dev machines I want to patch, and I give a cutoff time. My maintenance window would last for 5 hours. Like I want the system to be back online tomorrow morning when I log in. You give a cutoff time, and then that's 1 hour before closes. I think so midnight, so 4 a.m. you can try this out. And the next stage you tell what to do. Tasks defined. The first task here is you want to install, in this case, Windows updates is what we have shown, and you refer that with a document. So then the next is you could do reboot. You could do a variety of tasks, whatever you like. It gets fun when you are doing a lot of scripting and then sit back, relax and watch it. What's the word? Burn, if things don't mind, it happens. Right. Then you create your maintenance window for your different environments because you want to schedule it at different times. In our example, week 1, week 2, week 3, week 4, so 4 different maintenance windows. Right, so let's see how this all works. So week 1, you patch your dev machines, then week 2, QA machines, week 3, and finally you prod. In the end, your prod would have the same patches with dev, assuming you had updated the rules properly. Right, compliance. So this is that section I talked about with State Manager. Whatever you find out, it gets updated here. Patch compliance. Now, there are 2 sections here. Compliance type. One talks about patch, the other is an association. Association is that example that I said, firewall rules. You want to check something with State Manager and you want to report whether somebody opened up a firewall or somebody screwed up the IP tables. You want to find that out? You could check that association over here. So you don't even have to log in, and if you want to find out is it real time, the answer to that is because you're using State Manager, you define this is the time you want to run. You want to run it every 30 minutes or you want to run it every minute, you have that granular control over you. Right. So patch compliance, so you take a deeper dive there and you find out which are the instances which are compliant, which are the instances which are not. So you get that information available and then you can try to remediate it. Alright. So just to summarize how to patch your in-place machines. In-place are your static running EC2 instances that are not part of an auto-scaling group. You run it like forever if possible, or if you're running for decades, you got issues. So tag your instances, then basically create a baseline. After you create a baseline, then you run a state manager. State manager gives you that information in patch compliance. That is important. Otherwise, you may patch your machine, but the data may not be reflected in patch compliance. And then patching, you define the maintenance window, and this is the time I'm going to do it. And then finally, in the tasks, define what exactly you want to do. And that's basically install and reboot. So the next section is we're going to talk about is immutable servers. How are you going to patch immutable servers? So these would, I believe these would be the only two categories which EC2 instances would fall broadly. Don't go granular. So to define immutable, these are the servers that do not change, right? If there is a reason to change, you must replace it. Imagine getting a new laptop every month. The good thing is you get a new laptop, you get all the latest updates on top of it. The bad thing is you have to copy everything back on your apps, but you would control it using a pipeline. So if you were to patch an instance inside an auto-scaling group, you may patch it, but the problem is as soon as it gets terminated, a new instance gets launched, that patch is basically whatever you installed is gone. So the only way you could patch or update an instance part of an auto-scaling group is by updating the AMI. So you update the AMI and then you plan how are you going to move your AMI into your instances. So in this case, you probably create a new auto-scaling group and then finally delete it. So this brings some complexities, isn't it? So how are you going to manage this problem? So how do you automate the patching of an AMI? So I mean, if you were not patching without automation, you would go back to probably slide number 3, do login, manually update it, create image on your console and do it. You could do that, but that would be not a lot of fun, right? Otherwise, I wouldn't be here talking about how to do it. So you have to create an AMI baking pipeline. AMI baking pipeline defines that you are creating brand new images, updated images on a frequent basis. How frequent? It's your choice. We generally do it every month. It's kind of safe. The first process with AMI baking pipeline is you probably want to trigger it at a certain period of time. Say for example, 1 month. Every month you create an image. So to do that, you pick up a base image you can pick up from Amazon's console, and then you update your image, you harden it, you do all the magic you want to do, you install your antivirus softwares, all that your fancy company, organizations, policies that you may have, right? So you install all those and then you create your initial gold image. So that's something you typically do. Next is you have to validate whether everything is working fine. Don't want to validate, that's a different story, it's personal choice, or depends on your organization or your security team. They are the guys who would enforce this. So then you launch your instance, then you have tools like AWS Inspector where they want to see whether these are compliant with CIS levels and ensure they are validated. Everybody's happy, you create your gold image. So this is something you would release it every single month, right? Now, let me go back there. So if you want to find out, if you don't know how to start with an AMI baking pipeline, get to that link, just Google AWS Golden AMI pipeline. We are not using that model because it's quite generic. We modify it, and you probably modify it heavily to suit your requirements. But that's a starter if you don't have a pipeline for creating AMIs. Now, in the real world, you will create or manage auto-scaling group manually, right? If you're doing it, then it's kind of hard to solve or your apps, your app deployment and everything. It's not practical to do it by hand. So you would have a continuous deployment for creating it. So you'd have your developers checking your code into your favorite repository, and you'd have that triggering a commit would trigger a build. You could use any of these tools. These are all generic possible tools that you may have. And using those tools, you may update or manage your auto-scaling group. That's a nicer and better way to do it. And most of the organizations who are using auto-scaling group would fall under some of these methods. The logos might change, but the outcome is same, right? But that gives us a new problem, right? So on one hand, you have your EC2 instances You're creating a golden AMI every month. On the other hand, you have developers updating your apps. They aren't doing anything on the OS. When they do that, you probably won't have your system updated. They would update the apps. They would be patching the apps, but they would not be patching the OS. Even if you think about let them patch during deployment, it's not a good idea. You can ask me why later on. But so you would patch only your apps, and that's what your developers would do. So that is a different stage. So now you see there is a gap between creating a gold image. You would probably do it every month, and then you have your application developers doing and updating the auto scaling group. So how do you fix this problem? So this is where step functions would play a role. Step functions would help manage creating all these stuff. So I'm going to hand over to Sudev, who's going to explain how would you solve the problem with step functions.
Hello. Thanks, Amrith. So I'm Sudev. I'm a DevOps engineer with DXE Technology. So let's look at what step functions is, first of all. So what is step functions? Step functions is basically used to coordinate multiple AWS services to produce a desired outcome. Say, for example, you had like 1,000 Lambda functions and you wanted to execute in a particular order, you would definitely use step functions. Or say you want to have complex error handling in your Lambda functions, like say if the first Lambda fails, you want to attempt Lambda number 3 or Lambda number 4 and skip Lambda 2, things like that you could very well achieve using step functions. You could use step functions to basically have different Lambda functions and execute that on one Lambda function's output. And also, we could achieve the whole step functions functionality using one single Lambda function ideally, but we very well know that Lambda has a timeout of half an hour, so that wouldn't work. So let's, as we have seen, there are two different problems. One is your AMI baking pipeline, and your other problem is your deployment models, where your developers constantly make code changes and bring out new EC2 instances with the app. So we need to find a way how we can link these two processes, and the best way to link this is using AWS Step Functions. So let's, so consider we have a management account here. So this management account would be like, say, your generic account where you have all your monitoring tools, where you schedule your other regular management activities, etc. And let's consider we have CI/CD pipelines or auto-scaling groups running EC2 instances in 4 different accounts. And let's take an example of 4 different environments here: dev, QA, UAT, and prod. So now the first step is, as we've seen, the first process is getting a golden AMI. So we have the AMI pipeline which delivers a golden AMI in a periodic fashion, maybe weekly, monthly, or yearly. So we have a golden AMI which is landed in our management account. Now the whole idea is to share this AMI to the target accounts, the dev, QA, UAT, prod, and modify your auto-scaling groups and trigger your new EC2 instances or the deployments. So how do we move this gold AMI to your respective accounts? One way is to use step functions. So we could very well use many other tools like SSM automations. You could use, say, you could have Python code running somewhere else. So there are various ways to achieve this, but in this case we're using step functions. So now we wouldn't want to trigger your step functions manually, like on a periodic fashion manually, but we would want to trigger them automatically using another service. So that's where you have CloudWatch rules. So now consider it's, and again, we're using CloudWatch rules to set up patching, and it's on a weekly schedule like we saw earlier. So week 1 would be dev, week 2 would be QA, UAT, and prod. Now let's see what happens when your week 1 CloudWatch rule is triggered. It triggers your step function. Step function picks up the latest AMI from the management account, Now, how does it identify the latest AME? So we have some naming convention for the AME. So we name it with the name timestamp. So we fetch the latest AME using the date. And the next step is it it modifies your auto-scaling group in the target account that is dev as per the schedule. Similarly, QA and then the remaining UAT and prod. Now let's take a deeper look at what happens within the step function. So my step function starts. Its first step is to get your latest patched AME, which is shared by the AME baking pipeline. Once you have the latest AME, we need to take this AME and deliver to the target AWS account. So that's your next step. So you share your AME. Once you share your AME, you need to create a new launch configuration. Unfortunately, AWS doesn't allow you to modify an existing launch configuration. You can only create a new one. So there are various ways to create your launch configuration. You could use CloudFormation, again Lambda. You could use say SSM automations and things like that. But in this case, we're using CloudFormation because it's easier and native to AWS. And this CloudFormation template accepts my AME ID as a parameter. So it takes that and it deploys the CloudFormation. Now we very well know that CloudFormation does take some time for its deployment. So we need to do a constant check to see if it is actually deployed and it has actually created your launch configurations. Once we have the new launch configurations with the latest AME, we need to update our auto-scaling groups. So that will be the next step. So we modify our existing auto-scaling groups with the latest launch configuration. So this whole process is one side to the story. Now we have auto-scaling groups with our latest AME, which is completely patched. Now we need to ensure that the existing applications running on the EC2 instances need to make use of this AME. So what we do is, in this account, we have CI/CD pipelines running with code pipeline, code deploy, and code build. So we go ahead and deploy the pipeline. So as soon as we deploy the pipeline, in this case, we have a manual approval where somebody needs to get in and manually approve the pipeline. So what happens is because this is a patching activity, we very well know that it can be automatically approved. So that's why we have the other three states. And once all this is complete, it just goes and auto-approves the pipeline, and you have the new set of EC2 instances with your new auto-scaling group or new launch configurations. Now what happens if any of these states fail for some reason? We have configured another state called error patching, and it would raise appropriate alerts, monitoring tickets, and things like that to our queues. And that's it. I think we have a demo. Okay, so I'm manually triggering the step function over here. I'm starting with the environment as say we're patching the QA environment. So I start the execution and it goes through the various states within the step function. So you can see that it has already got the latest AME, it has shared it with the target account, that is QA in this case. Now it's waiting for the CloudFormation to deploy. So it does a constant check to see whether actually the CloudFormation has deployed and whether the launch configurations have been created. So while it's doing that, it would probably wait until you have your, So now you have your your launch configurations created. We can go ahead and modify. That's what you've seen. And then the last step is to deploy your pipeline so that it takes the new auto-scaling group into effect. And it waits again, as I mentioned earlier. We have a manual approval, and that's where you see the other three states, which is constantly checking if it's actually reached the manual approval state so that it can auto-approve the pipeline. So, yep, it has completed. So you can see it has completed the whole process. So you can see there's a new new CloudFormation to create the launch configuration created. After that, you can see that there are new launch configurations created for the month of May. Similarly, in this case, you're seeing 3 launch configurations because we have 3 different pipelines running in the account. Now you can see that it's using the existing auto-scaling groups are using a new launch configuration with the latest patched AME. And the last step is to trigger your pipeline. So my pipeline has been triggered. You can see my source stage is succeeded, my manual approval is approved, and now it's in the build stage. So actually it's doing the build of the application. So another reason why we trigger this pipeline is to just ensure that the patching hasn't broken anything in our application, so that the pipeline can do its normal test process. We can see that it's still not reached the deployment, it's still doing the build. So it's still waiting for the build to complete. Let's just give it a couple of minutes. Yeah, so once the build is complete, what code deploy does is, in this case, it's a blue-green kind of deployment. So it copies the existing auto-scaling group. Now the auto-scaling group has my latest launch configuration, and it just duplicates them. So you have a duplicate set of instances. We can see that all the states have neatly completed. So let's see if the deployment has started now. No, it's taking some more time. Yep, so you can see the build has succeeded successfully. Now the deployment has started. This is when your new set of instances would begin to deploy. And let's look at EC2 to see whether we have a new instance here. Yeah, you can see that there's a new set of instances coming, so we can confirm that this instance would definitely have the patched AME and the latest launch configuration. I think this is the way we can integrate those two issues, or those two processes. One is your AME baking pipeline, and the other one is your continuous delivery of your application.
Right, thanks Sudev for that. So we have established that you can now solve the problem of connecting and your AME baking pipeline and patch your immutable architectures as well. All your immutable servers can be patched. Now that brings your life cycle of your EC2 instances. Life cycles have been divided into various things, right? You have your short-term instances which last for few minutes, few days, few months. So these are part of your DevOps tool sets. Monolithic workloads are the in-place patching that you want to work about. Those are your reserved instances, which you would usually run it for a long time. This doesn't mean that you cannot have reserved instances for those if you know what is the instance type you want. But the point is, each and every instances, as long as it's EC2 if you're running, you have to find out the way in which you patch them. The patching strategy for each and every organization would be different. But no matter what kind of architecture you're running, if you're running those instances, you would find a way in which you could patch them. Right? So in the end, more and more deployments, you have new features coming up. Operating systems are bringing new features. This means you have new flaws. And therefore it is, and prior to this, a couple of years ago, your internal bandwidth was like nothing. Hacking was not so easy. Now with 100 Mbps at homes and everywhere, you know, hacking it's kind of easy to do it. So right now it's more important than ever. This is not a boring topic actually, because it's critical from a security aspect. So this was one example, but each and every solution that you have would be quite different. So customize it whatever you want to have. And if you can't patch your machines, just destroy them. It's quite easy to terminate an instance and quite easy to bring them back online. With that, I'm ending. Any questions that you can have? Oh yeah, that's a very good question. So you can patch your, one of your deployment could be that you could patch your machines, or you could fetch a latest and then put your app on top of it, redeploy. It turns out as as an organization, you come up with new projects, and this happened with one of our clients that they were very excited with deploying. They were used to deploy more and more AMIs, more and more updates for the initial few months. And then afterwards, for some reason, their project did not do so well. So their frequency of deploying apps reduced for that particular project. They moved on to others. This meant that they were running very old AMIs. So that's the reason you probably don't want to do, because in the end, some way or the other, your app development may slow down, and if it slows down, your auto-scaling loop would still be using an old AMI. So you may miss out on patching.
So you have two different approaches there. So if you have immutable things and you do AMI building, I get that part. But if you're doing the in-place patching, how do you make sure that when you do an app-get update on the first week, you get the same updates as if you do an app-get update on the fourth week when you do it on production?
Yeah.
You might not get the same updates.
Yeah,
right?
so in reality, AWS Patch Manager manages, it is not running an app-get update. Okay. It's getting an update to fetches, to get what are the packages I would want to install it. That's done in the background. Then it's going to evaluate an instance one by one. Each instance would be evaluated, and whatever you have approved, your patch baseline, that defines these are the patches that would be updated on your machines. So that is, make sure the patch baseline, that for all Linux machines, you have different set of repos. With Windows, it's a single wsys.cabinet file, but for Linux machines, it's quite different repos, as you can imagine. But you define that in your patch baseline.
Any more questions? Do you use a baseline each month?
Yeah, you don't have to do it every month. Once you define it, that this is for like 7 days after the vendors release the updates, so you could do that. It's just one-time activity that you want to acknowledge. This is called auto approval. But if you if you have a security team that defines and do it, they can define the baseline and push it as well.